Hi students, welcome to Max Point of View. Today we are going to learn uniform circular motion from the chapter Force Part C. As you know, we are just going to learn the topics, and after that, we are going to solve each and every question which is there in the exercise part, and that video will be available in the description box. All the videos of all the chapters will also be available in the description box. So before we learn anything from this chapter, we need to understand what are the topics we have. Uniform circular motion, uniform linear motion, centripetal force, and some example, centrifugal force, and some example. That's it. So part B and part C of this fourth chapter is very easy, and there is no numerical, just give reason questions and definitions. That's it. First we learn what is uniform circular motion, then uniform linear motion. What do you mean by uniform motion? In any object, moving with the same speed at any point of time is called uniform motion. What do you mean by uniform circular motion? In the same way, in any object moving with the same speed in a circular path, that is nothing but uniform circular motion. So what do you mean by uniform linear motion? An object moving in one direction with the same speed. We'll talk about velocity later. First we need to understand both the objects are moving with the same speed. That is why we are calling this as uniform circular motion, this one as uniform linear motion. Now we'll talk about, see here, speed remains same. Here also speed remains same. But what about velocity? Velocity is not constant in this case. Why? Because velocity is a vector quantity. Correct? Velocity is a vector quantity. What do you mean by vector quantity? It should have both magnitude and also direction. Speed is a scalar quantity. Speed has only magnitude. Magnitude means just a number. 30 km per hour, 40 km per hour, 25 meter per second. All those numbers are called magnitude. Speed doesn't have direction, but velocity has direction. See, we'll talk about this point now. Assume the object is here. Now the direction of this object will be in this way. Assume after crossing this point, from here it is moving now. After reaching this point B, the direction of the object will be in this way. So after reaching C, the direction will be here, and after reaching D, the direction will be here. So at every point, we have taken only 4. You can take any point. Here it will be here. At this point it will be here. So at every point the magnitude remains same, but what about the direction? At every point direction changes. So velocity is variable. Velocity is a variable quantity in this case. But what about here? Here the direction of an object moving in only one direction, right? The direction of object is not going to change. So here velocity remains same. So here we have variable velocity, there we have constant velocity. You need to understand, see, velocity depends upon two things. One, magnitude, that is nothing but the number. Then direction. Here in circular path, at every point direction changes. There the direction is in only one way, correct? In this way. So direction remains constant. So speed and velocity remains same. So if velocity changes, what will change? If velocity changes, what will change? Acceleration. What about acceleration? What do you mean by acceleration? Acceleration is nothing but rate of change of velocity. Rate of change of velocity. So here there is a change, correct? For every point, the velocity changes. What do you mean by rate? Rate means divided by time. So for changing the this one direction, it will take some time, correct? So acceleration is nothing but rate of change of velocity. So if velocity is changing, if velocity is variable, acceleration is also a variable. Okay, acceleration. A is also a variable. So we can call this as accelerated motion. Accelerated motion. Then what about uniform linear motion? Here speed and also velocity both are same. Here we are calling this as accelerated motion. Why? Because velocity is a variable quantity here, but here velocity remains constant. So this is non-accelerated motion. There will be no acceleration. So acceleration will be 0. Acceleration will be 0. So here acceleration is variable, there acceleration is 0. So these are the differences between uniform circular motion and uniform linear motion. If you know this much, aram se you can score anything as based on these two concepts. Okay, in your textbook they have written around 1.5 pages about these two topics. So if you know this much, so I'm giving you only important things. If you learn these things, then you are covering everything. Centripetal force is a force which is acting on a body which is moving in a circular direction, in the direction towards the center of the circular path. Okay, now I know, I understood. You just read the definition, but you need to understand it. Listen, centripetal force is a force. Okay, that is a real force. Okay, why I am telling that word real? I mean, you will get that later. Centripetal force is a real force which is acted on a body which is rotating in a circular path, which is moving in a circular path. So it is a force which is acted on a body which is moving in a circular path, and the force will be directed towards the center. This is the definition of centripetal force. Now we'll understand few examples. Listen, these are the examples for centripetal force. I know you can aram se write all these things in the exam, but based on these things you may expect give reason question also. What type of force we have in these kind of examples? We know centripetal force, but centripetal force is created by some other force. We need to learn that. So that we are going to learn using in examples. Listen. So here atom. Atom means we have nucleus and electrons revolving around the nucleus, correct? Between the negatively charged particle and the positively charged particle, protons, which is inside a nucleus. So here centripetal force, that electrostatic force, is created by the positively charged particles. Positively charged particles, which is creating that force, is very much important. In this case, positively charged particles are creating electrostatic force. Next one, planets. Planets moving around the sun. Here what type of force is created? Gravitational force. Okay, in this case it was electrostatic, but in this case it is gravitational force created by the sun. Created by whom? Sun, to make sure planets are moving around him. Next one, moon revolving around earth. Here also we can easily expect gravitational force, okay, which is created by earth. So which is created by earth. Earth is keeping the moon to make sure it is revolving around it. Next one, centripetal force created by tension. Tension of the string. Assume there is a stone. Okay, stone, you have attached a stone to the string, and now you have a stone and a string. If you rotate it, the stone will keep on moving in a circular path. So that centripetal force is created by the tension of this string. Tension of the string. So you need to know few things. What is that? Examples. Then what kind of forces are created? Okay, created by which one? If you know all these things, then I think you understood everything about centripetal force. Now we'll talk about centrifugal force. Centrifugal force is a force which is assumed by the observer. Which is assumed by the observer when a body is moving in a circular path, and the direction of the centrifugal force will be away from the center. Away from the center. See, there is no centrifugal force. This is just an assumption. That is why centrifugal force is called as fictitious force. Fictitious force means it is not a true force. Okay, there is no force called centrifugal force, that is a force assumed by the observer when an object is rotating in a circular path, and the direction of centrifugal force will be away from the center. This is for an example for centripetal force. So the direction of centrifugal will be away from the center. So what we can conclude easily, centripetal force is opposite to centrifugal force, but the magnitude remains same. Magnitude means number. What is the force value in, assume some force value in centripetal force, 10 Newton. The magnitude remains same, but the direction is opposite. So centripetal force is exactly opposite to centrifugal force, and centripetal force is a real force. Centrifugal force is a fictitious force. What do you mean by fictitious? It is not real. And what about the direction? Centripetal force will be towards the center, centrifugal force will be away from the center. That's it. If you know these kind of differences, then I think you have learnt everything about centripetal and centrifugal. There is one more experiment so that we can include both centripetal and centrifugal in one experiment. If we learn that, I think we have learnt everything from this part C. With a simple experiment, we will learn what is the difference between centripetal and centrifugal force. You know merry-go-round, right? Merry-go-round in the parks, it will be a circular disc. On that you will be standing and someone will be moving that, it will rotate in a circular path. That is nothing but the merry-go-round. Okay, so in the merry-go-round, exactly at the center there will be a stand, correct? There will be a stand. So we'll tie one ball to that stand. Now it is very straight, but when you just tie it, it will not be straight, it will be laying on the merry-go-round. Okay, now we'll make two people X, okay, and Y. Stand, X is standing outside and observing the merry-go-round, the Y is standing on the merry-go-round. Okay, now we will make this merry-go-round move, okay, in a greater speed or a maximum speed. Okay, now what happens, this X will observe Y and this ball, both are rotating in a circular path, correct? This X will observe that. What about Y? Y feel this ball is stationary, it is not even moving. So X will observe along with Y, ball is also making a circular path, but according to Y, if you are a person standing on the merry-go-round, this ball which is moving along with you, you feel this ball is not moving, it is stationary. Why do you feel like that? Because centrifugal force is a fictitious force, it is not a real force. Which is the real force? Centripetal force. But the thing is, centripetal force, okay, centripetal force and centrifugal force have same magnitude, but direction is opposite. If the force are equal and they are opposite in direction, what will be the net force? Net force, okay, net force will be 0. Net force will be 0. So according to this experiment, which is the real force? Centripetal force. Which is the fictitious force? Centrifugal force. What do you mean by fictitious force? It is not a real force, which is just assumed by the observer. That's it. I think we have learned the complete concepts. Now we are going to solve each and every question which is there in the textbook, and that video will be available in the description box. Thank you.